All right. Module 7, DHCP version 4. Yeah. So in this module, okay, it will explain about the concept of DHCP, configure Cisco iOS, DHCP version 4 server, and also configure DHCP version 4 for client. Okay, DHCP v4 concept. Okay, DHCP, yeah, assign IPv4 addresses and other network configuration information dynamically because desktop client typically make up the bulk of network address. DHCP v4 is extremely useful and time-saving tool for network administrator. A dedicated DHCP v4 server is scalable and relatively easy to manage. However, in a small branch of SOHO locations, a Cisco router can be configured to provide DHCP v4 services without the need for a dedicated server. Cisco iOS software supports an optional full features DHCP v4 server. And then DHCP v4 server dynamically assign or leases an IPv4 address from a pool of addresses for a limited period of time chosen for the server until the client no longer needs the address. Client lease information from the server for an administratively defined period. Administrator configure DHCP server to set the list to time out at different interval. The list is typically anywhere from 24 hours to a week or more. When the list expires, the client must ask another address, although the client is typically reassigned the same address. Okay, DHCP version 4 operation. Yeah. Okay. So DHCP v4 works in a client server mode. When a client communicates with DHCP v4 server, the server assigns or lists an IPv4 address to that client so that the client connects to the network with that list IPv4 address until the list expired. So the client must contact the DHCP server periodically to extend the list. So this list mechanism ensure that client that move or power off do not keep the addresses that they no longer need. When a list expired, the DHCP server return the address to the pool where it can be reallocated as necessary. Step 2, obtain a list. Okay, first of all, when a client boots, yeah, or otherwise wants to join a network, either these two, it begins 4 steps. First, DHCP discover. Second, DHCP offer. Third, DHCP request. Fourth, DHCP acknowledgement. So that's a final. So as this figure, yeah. So you can check. Okay, step to renew a lease. Prior to lease expiration, the client begins a two-step process to renew the lease with DHCP v4 server as shown in the figure. So DHCP request. So before the lease expires, the client send a DHCP request message directly to the server, yeah, that originally offer the IPv4 address. So if a DHCP acknowledge is not received, yeah, or DHCP ACK is not received within a specified amount of time, so that the client broadcasts another DHCP request. So that one of other DHCP v4 server can extend the list. So DHCP acknowledgement, yeah, DHCP pack. On receiving DHCP request message, the server verify the list information by returning a DHCP ACK or acknowledgement. Yeah. So note this message primarily the DHCP offer and DHCP pack can be sent as unicast or broadcast according to this standard. Yeah. IETF RFC 2031. So they're written in this document. Okay. So configure a Cisco iOS DHCP v4 server. Cisco iOS DHCP v4 server. Now you have a basic understanding of how DHCP v4 works and how it can make your job bit easier. A Cisco router, yeah, running iOS software can be configured to act as a DHCP v4 server. So the Cisco iOS DHCP v4 server assign and manage, yeah, IPv4 addresses from specified address pools within the router to the DHCP v4 client. Okay, so as illustrated in this diagram. All right. So step to configure Cisco iOS DHCP v4 server. Okay, use the following step to configure a Cisco iOS DHCP v4 server. Step 1. Exclude IPv4 addresses. A single address or a range of addresses can be excluded by specifying the low address and high address of the range. Excluded addresses should be those addresses that are assigned to routers, servers, printers, and other devices that have been or will be and also manually configured. You can also enter the command multiple times. The command is IP DHCP excluded address low address. Yeah, so this is the command. And then step 2, define a DHCP v4 pool name. The IP DHCP pool, yeah, and then the name of this command creates a pool with a specified name and put the router in DHCP v4 configuration mode, which is identified by the prompt router DHCP configure and then dash. We call this symbol Okay, so this is the prompt. Okay, after you type this command, yeah. Okay, hashtag. Okay, hashtag. And step 3, configure DHCPv4 pool. The address pool and default gateway router must be configured. Use the network statement to define the range of available addresses. Use the default router command to define the default gateway router. This command and other optional command are shown in the table. So this is the optional commands. Okay. Okay, here are the configuration example. Okay, so this line, so you can go through here, and also some exercise later we'll do on our lab activity. Yeah, all right. So DHCPv4 verification. Use the command in the table, okay, below to verify the Cisco IOS DHCPv4 server is operational. Okay, once you set, you have to verify that through this command. Okay. So verify the DHCPv4 configuration as shown in the example. The show running config, yeah, and section pipe DHCP command output display the DHCPv4 command configure on R1. So this pipe, yeah, section parameter display only the command associated with DHCPv4 configuration. Okay, here are the example. So verify DHCPv4 binding. As shown in the example below, the operation of DHCPv4 can be verified using the show IP DHCP binding command. So this command display a list of all IP address to MAC address binding that have been provided by that particular DHCPv4 services on that server. Yeah. Okay. So this is the one. So verify DHCPv4 static. The output of the show IP DHCP server static is used to verify that messages are being received or sent by the router. This command display regarding the number of DHCPv4 messages that have been sent and received. So verify DHCPv4 client receive IPv4 addressing. The ipconfig /all command, yeah, when issue on PC1, so it will display the TCP parameters as shown in the example here, yeah. Because PC1 was connected to the network segment 192.168.10.0. Okay, 10.0/24. So this the IP address. Then it automatically receive a DNS suffix IP address before address. And also subnet, default gateway, including the NS server address from that pool. Okay, this is the info that it will receive. Including this, yeah, yeah, this one, the one that orange color. So that's the info from the pool, yeah. Okay, so no DHCP specific router interface configuration is required. If a PC is connected to a network segment that has DHCPv4 pool available, the PC can obtain an IPv4 address from the appropriate pool automatically. Disable the Cisco iOS DHCPv4 server. The DHCPv4 service is enabled by default. To disable this the service, okay, use the no service DHCP global configuration mode command. Use the service DHCP global configuration mode command to re-enable the DHCPv4 server process as shown in the example. Enabling the service has no effect if the parameters are not configured. Note, clearing the DHCP bindings or stop and also restarting the DHCP service may result in duplicate IP addresses being temporarily assigned to the on the network. Okay. So DHCPv4 relay. In a complex hierarchical network, enterprise servers are usually located centrally. These servers may provide DHCP, DNS, TFTP, and FTP services for the network. Network clients are not typically on the same subnet as those servers. In order to locate the server and receive services, clients often use broadcast messages. In the figure, so this one, figure. PC1 is attempting to acquire an IP address from the server or from DHCP server using a broadcast message. In this scenario, R1 is not configured as DHCPv4 server and does not forward the broadcast because the DHCPv4 server is located on a different network. So that PC1 cannot receive an IP address using DHCP. So R1 must be configured to relay DHCPv4 message to the DHCPv4 server. Yeah. So configure R1 with the IP, configure R1 with the IP helper address, and then address interface configuration command. This will cause R1 to relay DHCPv4 broadcast to DHCPv4 server. As shown in the example below, this example, and this one a verification. The interface on R1 receiving the broadcast from PC1 is configured to relay the DHCPv4 address to the DHCPv4 server at 191.168.11.1. When R1 has been configured as a DHCPv4 relay agent, it accepts broadcast requests for the DHCPv4 service, then forward those requests as a unicast to the IPv4 address 192.168.11.6 so that the network administrator can use the show IP interface command to verify that configuration. Other service broadcast relay. DHCP is not the only service that router can be configured to relay. By default, the IP helper address command forwards the following 8 UDP services. Okay, port 37, which is a time, port 49 for TACACS, port 53 DNS, port 67 for DHCP boot TP server, port 68 for DHCP boot TP client, TFTP for port is a 69, 137 for NetBIOS name service, and also finally is 138 for NetBIOS datagram service. So there will be a packet exercises for configuring DHCPv4. Yeah. So we can do this through the NetACAD, and also finally we got a packet tracer exercise as well regarding this issue, yeah, configuring DHCPv4. Configure DHCPv4 client. So Cisco router as a DHCPv4 client. There are a scenario where you might access to a DHCP server through your ISP. In these instances, you can configure a Cisco IOS router as DHCPv4 client. Sometimes Cisco routers in a small office or home office SOHO and branch site have to be configured as DHCPv4 client in a similar manner to client computers. The method used depend on the ISP. However, in its simplest configuration, the Ethernet interface is used to connect a cable or DSL modem. To configure an Internet interface as a DHCP client, use the IP address DHCP interface configuration mode command. In the figure here below, assume that an ISP has been configured to provide select customers with IP address from 209.168.201.0, yeah, network range after the G0/0 is configured with IP address DHCP command. Configuration example. To configure an Ethernet interface as a DHCP client, use the IP address DHCP interface configuration mode command as shown in the example. This configuration assumes that the ISP has been configured to provide select customer with IPv4 addressing information. The show IP interface G0/1 command confirm that interface is up and the address was allocated by a DHCPv4 server. Okay, so this is the example of the configuration, and this is the verification command. Yeah. Home router as a DHCP client. Home router are typically already set to receive IPv4 addressing information automatically from the ISP. This is so that customer can easily set up the router and connect to the internet. For example, the figure in the figure below shows the default one setup page for a packet tracer wireless router. Notice that the internet connection type is set to automatic configuration DHCP. This selection is used when the router is connected to a DSL or cable modem and act as a DHCPv4 client requesting an IPv4 address from the ISP. Various manufacturers of home router will have a similar setup. Okay, so this is 7.4 module practice and quiz. So there will be another packet tracer for implementation of DHCP. So you can go through this in our NetACAD website. And this is for the real lab, implement DHCPv4. Later we'll try to do in our lab. Yeah. All right. What did I learn in this module? So lots of things that we learned just now regarding the DHCP server dynamically assign or list IPv4 address to client from pool of addresses for a limited period of time chosen by the server until the client no longer needs the address. And then we got the DHCP list process begin with the client sending message describing the services of DHCP server. If there is a DHCP server that receives the message, it will respond with IPv4 address and possible other network configuration information. And the client must contact the DHCP server periodically to extend the list. Yeah. And then when the client boots or otherwise wants to join, it begins 4 steps to process in order to obtain the IP address. So DHCP discover, DHCP offer, DHCP request, and finally DHCP acknowledge. Prior to list expiration, the client begins a 2-step process to renew the list with DHCPv4 server using DHCP request later than DHCP acknowledge. And we got the Cisco router running. Cisco IS software can be configured to act as the DHCPv4 server. Use the following step to configure a Cisco iOS DHCP server, and then exclude IP addresses, define a DHCP pool, and also configure DHCPv4 pool. So this is verification command that you're going to use that, and then DHCP server is enabled by default. To disable that, how use this command in order to disable the service for the DHCP. And we got this next network client are not typically on the same subnet as enterprise server providing DHCP, DNS, TFTP, and also FTP services for the network. In order to locate the server and receive services, client often use broadcast messages. The router must be configured to relay DHCP message to the DHCP server. So the admin can configure the router with the IP helper address interface configuration command and use the show IP address in order to verify that. By default, the IP helper address command forward the following 8 UDP services. This one. And finally, to configure an Ethernet interface, SDV client use the IP address DHCP interface configuration mode command. Home routers are typically already set to receive IPv4 address information automatically from ISP. So the internet connection type is set to automatic configuration DHCP. This section is used when the router is connected to DSL or cable modem and act as a DHCP client requesting an IP address from the ISP. All right, that's all for this chapter. Thank you for listening and watching. Bye-bye.